Now let's discuss about the moment of inertia. Heavier the object, more difficult it is to move. So have a look at this diagram on the right hand side. You can see we have a 400 kilogram mass and the force applied to move it is much larger as compared to a smaller 40 kg mass. Hence, we can deduce that if the mass is large, then it is difficult to move. On the other hand, if the mass is small, then it is easier to move. And now, if you analyze, mass has a direct relation with movement. So the concept is mass of a body is a measure of linear inertia of the body. That means if you're having a larger mass, larger m, then the inertia of the body to movement is more. For example, imagine a large truck which is having a large amount of mass. Since it is having a high mass, it is very difficult to make the truck move. But on the other hand, if the truck is already moving, then it is very difficult to stop that truck. That is why we say mass of the body is measure of the linear inertia. More the mass, more will be the inertia. Now, in this chapter of rotational mechanics, there is a term which is analogous to mass of the body, and that is moment of inertia. So, let us write the corresponding statement for moment of inertia. So, like mass of the body was a measure of linear inertia, similarly, moment of inertia is a measure of rotational inertia of the body. Which means if an object has a greater moment of inertia, it is very difficult for it to rotate and vice versa. Now, let me explain this with an example. So over here, you can see we have a cylinder and both cylinders are of course rotating, but the axis of rotation is different. In the first case, the axis of rotation is passing through the center and it is going across the entire body. Hence, the cylinder is rotating in this direction which the arrow is representing. Similarly, in situation 2, it's the same cylinder, but it is rotating about this line which is passing through the center. So it is the same object, same cylinder, but the axis of rotation is different. Now think in which of these cases it is difficult or easier for the cylinder to rotate. Now, if you analyze the case 1, when the axis of rotation is passing through the entire body of the cylinder, now just use some basic practical knowledge. It is easier for the cylinder to rotate if the axis of rotation is as shown in this figure. And hence, in this case, let us state that it is easier for us to rotate the cylinder in this orientation. And since it is easier to rotate, it is having a smaller moment of inertia. On the other hand, in case 2, it is slightly difficult for the cylinder to rotate if the axis of rotation looks like this. So difficult to rotate in case 2. And since it is difficult to rotate, it is going to have a large moment of inertia. So just like mass, which had a direct connection with movement, moment of inertia is connected with rotation. So that is why we said moment of inertia is measure of rotational inertia of the body. So for example, if you consider an object which is having a very large moment of inertia, then it will require a lot of force for the object to rotate. But if that same object is already rotating, then it would require a lot of force to make it stop. This is called the rotational inertia. And now, if you analyze these two figures, even though it is the same object, it is one cylinder, but the moment of inertia is different. So, moment of inertia depends on how the object is being rotated. That is why now the actual statement, which is important, is moment of inertia depends on the axis of rotation. Now, this is extremely important because mass of an object is always a constant that is not going to change. But moment of inertia does change depending on the axis of rotation. And now, if you recall the principle of torque, torque also is dependent on a particular point. So, like the value of torque is variable, so the moment of inertia is also variable dependent on the axis of rotation. All right, so now we discuss what is moment of inertia. Now we come to the moment of inertia formula. So, consider a specific situation where we are having an object of mass m and it is rotating about a line. So, consider this yellow object mass m, axis of rotation is this vertical line. Now the distance of the mass from this axis of rotation is r. Now let's say this object is rotating in a circle around this axis of rotation. Now whenever you have a case where you have a point mass rotating about a line, moment of inertia is given by this formula mr square. So product of mass and the square of the radius. In this case, r is radius, but we should know what is the general definition of r. So r stands for distance of the mass from the axis of rotation. And in this diagram, this r is actually the radius of the circle. Now, coming to the unit. Moment of inertia is m into r square. M is mass, unit is kilograms. R is distance, unit is meters. So the unit of moment of inertia will be kilograms into meter square. And this point onwards, please remember the formula I is equal to mr square is for an object of mass m which is rotating about a particular line. So this was case one where you had only one object which was rotating. Consider another situation, which is a system having multiple masses rotating about the same line. So have a look at this diagram. We have three masses m1, m2, m3. Now each of these masses is at a different distance from this particular line. So how do we find the moment of inertia of the entire system? We will have to add mr square for all the masses. So what do I mean? The moment of inertia formula will look like this: m1 r1 square plus m2 r2 square plus m3 r3 square, where I stands for the moment of inertia of the entire system. Now, in the exam questions, if you have been given a system of bodies, then it is important for us to find the moment of inertia of the entire system. And now let us solve a question based on this. So please focus on the two formulas. If it's a one body system, moment of inertia is mr square. If it's a multiple body system, the mr square for all particles is just added. And now let's solve a question. So here we have two 1 kilogram masses. So these pink balls are the 1 kg masses attached to a rod of negligible mass. So this rod A, B, C, this is the entire horizontal rod. We need to find the moment of inertia of the body if the rotation is about the axis A. So in the diagram also I have shown this dotted line is the axis of rotation. Consider the rod to be hinged at the point A and it is rotating like this, like the arrow is representing. Now let's recall the formula for moment of inertia. I stands for m1 r1 square plus m2 r2 square. We are having a two body system. Let us consider m1 as the first red ball. Mass is 1 kilogram, so m1 will be 1. And what is r1? R1, if you remember, is the distance of the object from the axis of rotation. So for the first ball, this is that distance, which is 20 centimeters, which we need to convert into meters. 20 centimeters is 0.2 meters. So let's write 0.2 squared plus the other mass is also 1 kilogram. So M2 is also 1 multiplied by R2. R2 will be the distance of the second ball from the axis of rotation. So the distance from the point A all the way till the second ball. And that distance is 20 plus 20 plus 20, which is 60 centimeters, which is 0.6 meters. And if we solve this 0.6 square, let's solve. So we'll get 0.04 plus 0.36, and if we solve this we are going to get zero point 0.4 as the value. Now the unit of moment of inertia we have already discussed will be kilogram meter square. Hence this is the moment of inertia of the entire system but about the axis A. Now remember we discussed that moment of inertia depends on the axis of rotation. So in this question the axis of rotation was on the point A. Now consider the same setup but the axis of rotation is B. So calculate the moment of inertia of this entire system if the rotation is about the axis B. So in the diagram I have shown this green dotted line is the axis of rotation. So consider the point B to be hinged. So the entire rod is rotating in this fashion. And let's use the same formula. I is equal to m1 r1 square plus m2 r2 square. Masses are 1 kilogram r1. Distance of the red ball from the point B, this is 20 centimeters, which is 0.2 squared plus m2 is also 1. And the distance of the second ball from the point B is also 20 centimeters, which is zero point 0.2. So let's solve this. We'll get 0.04 plus 0.04, which comes out as 0.08, and the unit will be kilogram meter square. So this is the value of moment of inertia, but if the axis of rotation is point B.